Okay, now let us examine each feature and let us know how they are contributing their effect on the target variable, estimating the target variable. And here I'm using a plot which is basically the line plot, which actually plots the variation, which is that nothing but the proportionality of the specific feature with respect to the target variable. So these are the basic syntax. You don't need to even recognize them. So let me say you once again how we are going to know syntax. So if you press shift plus tab, you are going to get the signature of that particular function, and then you can submit all those values. I'm gonna create separate video on how we gonna use these plots. So for now let us proceed. So when I plot this, what you can observe is, as my sepal length increases, my target variable, that is, I have my target variables are 2, 1 and 0, isn't it? So from this visualization I can conclude that at very low sepal length my flower is the first type, which is nothing but setosa, isn't it? So when the sepal length is about 5.7 to 6, my target variable is probably 1, which is nothing but my versicolor. So, and when my sepal length is maximum, I can blindly conclude that my target variable is 2, which is nothing but Varzenica. So from this visualization, I was able to conclude that as the sepal length increases, what happens is the probability for the occurrence of the target variable to be 2 is also increasing, isn't it? So in this way we are going to fetch the insights from our data using visualization. And now bar plot, actually this is another kind of plot. If you can see here, I'm using, and here also you can basically don't need to remember the syntax. You can basically use shift plus tab to view the signature of this method, and I'm gonna make video, don't bother about it. So in this I have sent my sepal length as one variable and my target as another. So bar plot, what this does is, actually you can see here bars. When my sepal length is 7, my maximum kind of flower, which is nothing but type 2, and most of the sepal length when it is 6, it is either 1 or 2, because if we see for the sepal length being 6 centimeters, it might be target 1 or 2 most probably. So in such way bar plots are basically used to get few more insights from the data. And what I have done here is I used subplot to plot all the other features. Let me explain how I did it. I have used the basic for loop, and I have used the enumerate, because when I pass my data frame object, it in every iteration it basically returns me the index and the column. So I'm gonna use this index and column to plot my subplots, and don't bother, I'll also make a video on it how to draw subplots. So I'm iterating through all the columns of the data frame, and I'm drawing the line plots. And if you can observe here, my sepal length is directly proportional. That means when my sepal length increases, my chance for Virginica to be the target variable also increases, and petal length also does the same, and the petal width actually also does the same. But if you can observe sepal width, what happens is when its size is less, the target variable is being 1, which is nothing but versicolor. So with the help of for loop we can basically have the insights regarding all the features in this way with the help of subplots. And same for loop I have used to draw bar plots. And now if you can see here, we have a good differentiation between the petal width and the target variable. If you observe here, what happens is when my petal width is very less, the most of the cases the flower is zero kind, and my petal width is more. Most of my flowers are of the kind Virginica. So in this way we can also use my bar plots. So I have got insights using each of the variable, and now I'm going to analyze bivariate analysis. So friends, let's begin how bivariate analysis is done. Actually here we are again going to use Seaborn, which has a function heat map, which has a method heat map. Heat map is very useful in drawing the perfect insights from the features. Actually heat map is basically used to basically we are passing a matrix which is nothing but correlation matrix. Basically friends, correlation matrix computes the correlation between each feature. Correlation basically tells that if it has high correlation, then the features are highly proportional to each other. So let me print the correlation for my data frame matrix, correlation matrix. So if you can observe, when I print correlation data frame dot correlation, I have got the relation between each of the feature. Each of the feature has the relation with respect to other feature, isn't it? So here negative correlation means that these two features, which is sepal length and sepal width having less correlation, that means that they are not that proportional. So this kind of analysis basically helps us in predicting the proportionality through a target variable. Because if you observe here, when I have sepal length and target variable, they have a high positive correlation. That means that sepal length and target variable have high correlation, and sepal length, including the sepal length to my model, will basically have an high proportionality in predicting my target variable, isn't it? So similarly, now if I consider sepal width, what I can observe is it has negative correlation. That means with my feature sepal width, it cannot be used for predicting target variable because it doesn't have that kind of correlation with my target variable, isn't it? So I can drop my sepal width from my further study from this. So this is bivariate analysis. That is nothing but having the correlation between each of the features, so that we can know how each feature is depending on one another, and at the same time we can also know the features which are affecting the target variable most efficiently. So from this, and when I pass this correlation matrix, which is nothing but the data frame which I got through my heat map, what it actually does is it gives a basic visualization from which we can visualize it more precise, more nicely, or more efficiently, to say it precise. We can visualize it more properly. So if we see with respect to my target variable, I have high correlation with my petal width, which is 0.96, and high correlation with my petal length, which is 0.95, and negative correlation with sepal width. So what I'm going to do is I'm going to drop my sepal width because it has a negative correlation, so I cannot further include it in my model prediction. It doesn't have good correlation with it. So basically I'm going to include sepal length petal length and petal width. So here we can observe that petal length, petal width, sepal length are highly correlated with target variable. So I'm going to include them as in final features. But if you observe here, I have only included petal length. Petal length. I mean, I have only included petal width, but I didn't include petal width. Petal. I have included petal width, but I didn't include petal length because, as we observe, petal length and petal width are having same kind of a correlation. We can drop any one of them because they have 0.95, 0.96 of correlation. So I can drop one of them and I can choose any of them. So I have chosen petal width over petal length, and I have considered them as my final features. And now I'm making a new data frame, which is my final data frame. You can basically observe here I'm sending these columns from my original data frame. Select original data frame, I'm selecting this column, and the respective data frame is being sent to final data frame. And at the same time I'm also considering target data from my original data frame. So you can observe this is my final data frame. These are the variables which I have considered from my data visualization, which is nothing but exploratory data analysis. I have considered this pedal width and sepal length as the features which are highly affecting my prediction and target variable. So this is my final data. So let us start training my model.